All right, if the first part of 5.2 wasn't enough, I have some extra examples for you now. So we are going to verify that this is an identity. Again, we choose the more complicated side to work with. I think the left. I look at this, nothing really stands out to me, so I'm going to change everything into sines and cosines. Tangent becomes sine of x over cosine of x. And then I'll change cotangent. Cotangent is cosine of x over sine of x. And then I'm going to simplify this second fraction because those signs cancel. And then I'll distribute. So I don't need a parenthesis there. There we go. And my cosines cancel on this first part. So sine of x plus cosine squared of x equals exactly what I was trying to get. And my answer is done. All right. All right, we're actually going to skip this one because we already did this in the first video. So on to this one. You want to choose the trickier look inside. Now that's hard to say on this one. When I can't decide, I either choose at random, whichever side I feel like, or I go with the side that isn't in terms of sines and cosines. So I'm going to work with the left. All right, I know that 1 plus cotangent squared. That's cosecant squared, so let's go with that. And now I'll go sines and cosines. Tangent squared is sine squared over cosine squared. And then cosecant squared is 1 over sine squared. And then those sine squareds cancel, giving me 1 over cosine squared of x. Now you might say, all right, let's make that secant squared of x and call it a day. But that's not what I'm trying to get to. Always keep in mind what you're trying to get to, because I can rewrite cosine squared as 1 minus sine squared. And that's what I was trying to get to. So that is actually where I want to be. Oops, can't see that part. All right. This one is using those odd and even identities. So let's start with cosine of negative x. Cosine of negative x is just cosine of x. All right, and then tangent of negative x is negative tangent of x. So I'm going to stick a negative out front. All right, I know I'm trying to get to negative 1. Cosine over sine. Let's actually stick my negative out front. Let's split this apart. I have 2 ways I could go from here. I'm going to say, all right, tangent is sine over cosine. And look at that, the sines and the cosines both cancel, leaving me with negative 1, which was my goal from the beginning. All right, this one, obviously the trickier side is the left. If you paid attention earlier, this looks a lot like one we already did, but it's a minus, not a plus. So first step would be get a common denominator. So my first fraction, I'm going to multiply by 1 plus sine of x. Oops, that's plus. So I get 1 plus the sine of x over 1 minus sine squared of x. All right, let's get a common denominator for that second one then. So the second fraction, I'm going to multiply by 1 minus sine of x in the numerator and denominator. And so I get 1 plus the sine of x over 1 minus sine squared of x minus 1 minus the sine of x over 1 minus sine squared of x. Now I'll combine my two fractions. Be careful though, this minus. 1 minus 1 is 0. Sine of x minus negative sine of x is 2 sine of x. And my denominator stays the same. Now I'll say, okay, well, 1 minus sine of x, or sorry, 1 minus sine squared of x is cosine squared. And then I'll break it into separate fractions. 2 times sine over cosine times I'm left with 1 over cosine. And I know sine over cosine is tangent. And 1 over cosine is secant. And that is exactly what I was trying to get to. All right. Very similar type of problem, but my fractions are on opposite sides. This one does not have a simpler side. Choose one of them to work with. All right? I personally want to work with the left. I know that in order to turn a 1 minus sine into a cosine, I need to make this into a cosine squared by multiplying by the conjugate. So I'm going to take that left-hand side, and I'm going to multiply by 1 plus sine of t. You might notice also that that's the final numerator I want to end with. So I'm not going to distribute it because I think that'll be counterproductive, because I want that in my answer. So I get 1 minus sine squared of t. And look at that, 1 minus sine squared is cosine squared. And one of my cosines cancels, giving me 1 plus the sine of t over the cosine of t, which is exactly what I want. All right, choosing the more complicated side on this one is, again, a trick. I actually think I'm going to go with the right, because I feel like that one might look more complicated to me right now. Let's try it. I don't see anything helpful though, so I'm going to start by changing it all to sines and cosines. Cotangent is cosine over sine. You may see sometimes that the turning everything into sines and cosines is just all done all in one step. It's better to show every step, but not a deal breaker always. So secant is 1 over cosine. All right, now let's combine those fractions. 1 minus sine of u over cosine of u. Okay, well, my cosines cancel, making it 1 minus sine of u over sine of u. Now I know that I could make this into cosecant u minus 1, but that's not where I want to get to. Always keep what you want in mind. I know that to end with a cotangent, I need a cosine in the numerator. So I'm going to next step, sorry. I'm going to multiply by the conjugate again. Let's see what that does for me. So I get 1 minus sine squared of u over, let's distribute. Sure, why not? Sine of u. Maybe not. Okay. I was going to distribute, and then I just apparently didn't. So now I have cosine squared in the numerator. And I know I want to end with a cotangent of u, so I'm going to take one of those out right now. Cosine of u over sine of u times 1 over 1 plus sine of u. All right, I've got one of my cotangents of u. Oh, sorry, I forgot the cosine of u. There we go. All right, now because of the way I went about this problem, I have to get really creative right now. I'm going to use a reciprocal identity. I'm going to write sine as 1 over cosecant. And then I need this one to be cosecant over cosecant. So I'm going to way up here again. So I have cotangent of u times cosine of u over cosecant of u over cosecant of u plus 1 over cosecant of u. Combine those into one fraction. Keep my equal sign. I have cosine of u over cosecant u plus 1 over cosecant u. Cosine of u multiplied by the reciprocal of that denominator. And now I have cotangent of u times cosine of u times cosecant of u over, I'm just going to flip that around real quick, 1 plus the cosecant of u. And now, cosecant, this one in the numerator, I'm going to change into 1 over sine. Because I want to keep the one in the denominator because that's what I'm trying to get to. Cosine times 1 over sine makes a cotangent. And now I finally got to cotangent squared of u over 1 plus cosecant of u equals cotangent squared of u over 1 plus cosecant of u. I'm going to put my arrow in all of these spots. This is probably not the best way to go about this problem, but it worked. There's always a way. All right, this one, again, I would get that common denominator situation. So first fraction, I'm going to multiply by the conjugate. Oops, secant of x plus 1. There we go. That gets me secant of x plus 1 over secant squared of x minus 1. And then same thing to the second fraction. Multiply by secant of x minus 1. So I get secant of x plus 1 over secant squared of x minus 1 plus secant of x minus 1 over secant squared of x minus 1. Combine my like terms, I get 2 secant of x over secant squared of x minus 1. Now I could change secant squared minus 1 into tangent squared. And now this looks really wonky because to get to 2 cotangent cosecant is going to be a challenge. So what I would do, rewrite it as division, and then change everything to sines and cosines. And so I have 2 times 1 over cosine of x divided by sine squared of x over cosine squared of x. And I gotta go up here again. Flip over that second one. 2 times 1 over cosine of x times cosine squared over sine. squared. And now one of those cosines cancels. Now I rewrite it to fit what I need. I need a cotangent, which is a cosine over sine. And a cosecant, which is a 1 over sine. And look at that, that's right. It's just getting it to that spot now. One step at a time. 2 cotangent cosecant equals 2 cotangent cosecant. And draw my big arrows in so I remember I just brought that down. And I have one extra bonus problem. This problem deals with ln's. Remember that ln's added together means I can multiply them. So I can actually take cotangent times secant times sine. And that's going to equal 0. I can actually solve this whole problem because I'll change everything into sines and cosines. I'm going to do that all at once just because it's our last example. Now look at that, my cosines and my sines all cancel. I have ln of 1 equals 0. And that is absolutely true. All right, those are all your examples for this section.